Hi, I'm Rob Fierstein, and I'm the Solution Engineer Lead for Public Safety at Esri. Thanks for choosing to watch my presentation. Once you're finished, come find me in the public safety area during the conference, or shoot me an email. You can find my contact information on the last slide. I hope you find this presentation on criminal intelligence analysis using ArcGIS Pro Intelligence useful. ArcGIS Pro Intelligence is Esri's powerful desktop application for intelligence professionals. ArcGIS Pro Intelligence, or ProIntel for short, supports spatial, relational, and temporal analysis across a wide variety of data formats. ProIntel is tightly coupled with the ArcGIS platform, supporting data sharing across ArcGIS Online and ArcGIS Enterprise, or completely disconnected in a single workstation as needed. In this presentation, I'll cover an overview of ProIntel, what's new in 2.6, I'll analyze location intelligence to find hidden relationships across a large GPS dataset using the new movement analysis tools. We'll then use link charts and the new link analysis tools to find hidden relationships in a dataset for a bank robbery series. ArcGIS Pro is built and designed for GIS professionals by GIS professionals. Since the early days of ArcGIS Desktop, intelligence professionals have used the software to support their workflows to conduct analysis and create meaningful decision support visualizations. With ArcGIS Pro Intel, we have an analytical desktop suite for intelligence professionals built by intelligence professionals utilizing the decades of development and knowledge behind ArcGIS Pro. ProIntel offers the user a new experience beginning at the start page. This is the default start page, but organizations or individual users can easily customize the home page to represent their organization, unit, or mission. I've switched from light theme to dark theme and changed out the background image for a UC 2020 graphic. In the carousel, I can easily navigate to and open my recent projects. I'm able to browse and open my other saved projects or create a new blank project. For organizations with more defined workflows, custom project templates can be deployed with ProIntel to enable intelligence analysts to begin working without starting from an empty project. Project templates are designed to enable the analyst to conduct a defined workflow. These templates can include connections to folders, databases, and servers, can provide either complete datasets or empty schema layers, custom analytic tools or models, and project templates can deliver organizational symbology styles and standard layouts for finished products. As an intelligence analyst, I rely on mapping and spatial analysis to understand where activities have occurred, the patterns of the threat, and ultimately where action needs to take place. I also need to understand how events occurred over time and how things are related. To do this, ProIntel includes timelines and link charts to visualize and analyze temporal and relational data. ProIntel has tools like batch import data for bringing data in from several formats to begin supporting analysis. There are lots of custom tools in ProIntel that have been created to meet the growing needs and requirements of the communities. For me, in ProIntel, it's the little things. Two of my favorite features I want to highlight are the custom quick access toolbar at the top of ProIntel. While working on projects, there are features I need to access all the time, and I don't want to go searching through all the ribbons to find them. So popular and common functions have been added to the top to make this easy for users. The final feature I'd like to highlight is the symbology that's included. There are dozens and dozens of new symbols created to meet user requests from the community. The intelligence solutions team that builds ProIntel partnered with a few lead agencies in the community to create authoritative symbols for users to leverage. Take a look at the symbology offered in ProIntel and let us know if there are any symbols you'd like to see created to support your work. ProIntel sees some major enhancements at 2.6. First, ProIntel no longer requires an additional download or separate install. It's now included as part of the ArcGIS Pro download and install process. During the install process, users are prompted with the option to install Pro and ProIntel, or just ProIntel. All the online or disconnected documentation has also been updated to include all the ProIntel help. The new movement analysis tools make it easier to find relationships in your location data. I'll demo these new tools here in just a minute. We'll also take a look at the several new link analysis tools that have been added to the link chart interface. There's also been several enhancements to the UI to help improve the user experience. A few weeks ago, I received an email from a GIS lead at a federal public safety agency that is also responsible for supporting the organization's intelligence efforts. This feedback in this email is exactly what we're trying to achieve with ProIntel, putting the right tools at the user's fingertips. Let me provide a brief overview of a couple of movement analysis tools before I go into the first demo. The movement analysis tools in ProIntel are designed to support those conducting pattern of life analysis, ABI, or law enforcement investigations. Lots of intelligence data is derived from transactions, mobile devices, and surveillance. The movement analysis tools are designed to aid with determining the spatial and temporal relationships between people, places, and events. In 2.6, there are 3 tools for movement analysis. Let's first look at the Find Co-Travelers tool. This tool looks at a single data set to identify 2 individuals that are within spatial and temporal proximity to one another. Depending on the accuracy and reporting frequency of the data you're analyzing, you will need to adjust the tool's parameters. A pattern of spatial and temporal coincidence may indicate that the individuals were traveling together. The output of this tool is a new point data set with 2 new columns of information, one depicting the distance difference and the other the time difference between the 2 points identified in the co-traveler record. The next tool is Find Meeting Locations. The Find Co-Travelers tool found coincident points that casually shared spatial and temporal proximity. The Find Meeting Locations tool looks at a single data set to find 2 unique features that share the same proximity for a prolonged period. Like the last tool, the parameters of this tool can be changed depending on the accuracy of the data and frequency of the time intervals. The output of this tool is a point dataset and a polygon or area dataset. The point dataset contains the identification value for each subject, the meeting duration, and the date time for the meeting start and end. The area dataset contains the perimeter representing the meeting area. This tool also takes advantage of the geoanalytics desktop tools available with an advanced license. These tools, like the geoanalytics server, utilize parallel process across multiple cores on your computer to support analysis. To put this in perspective, there is a similar tool to find meeting locations called Find Space-Time Matches. And this tool doesn't leverage the geoanalytics desktop tools. Processing the same data set of about 155,000 points with the Find Spacetime Matches tool takes 33 minutes to complete and create an output. The Find Meeting Locations tool only takes 75 seconds for the same data set. So those of you Intel analysts without an advanced license, looks like it's time to upgrade. Okay, that's enough PowerPoint. Let's see these tools in ProIntel in action. To set this up, in this scenario, we have about 155,000 GPS points from 57 individuals in Southern California. For demo purposes, let's say these individuals are on parole or probation, and as a condition of their release, they are wearing GPS ankle monitors and aren't allowed to co-locate with other parolees. Let's use ProIntel and the movement analysis tools to determine if any parolees are violating the terms of release. Let's look at the GPS data we're working with. We have the GPS date field. We also have the GPS ID field that we'll be using for the unique identifier for each of the individuals. And we're working with about 156,000 records. Let's use the symbology in ArcGIS Pro Intelligence and change up these symbols to better show each individual's GPS movement. We'll use the that GPS ID field. And then we'll go in and we'll try to find a symbol to represent each person. So here we're looking at all of the symbology, like I said, dozens and dozens and dozens of different symbols that have been added with ArcGIS Pro Intelligence. We'll use this symbol right here for the person. And now that it's loaded up, let me go in and just change the color schema. There we go. Now we have a symbol for each individual that's being tracked via GPS. In order to use some of these tools, we need to enable the time. So we're going to do that on the GPS data using that date field. Now that that's done, let's go ahead and find the meeting locations for these individuals that are being tracked. We'll input the GPS information. Let me just add that this is going to be the areas output for the tool, and that this is the points. The unique identifier, and then we'll use the defaults for search distance, and we're going to let this run. And there's our outputs. So the top one, our point output for 5 meeting locations. Let's go ahead and change the symbols on this. They're kind of hard to see. We'll just use something simple, like a location marker. And change it to blue real quick so it stands out. Okay, that's better. Okay, so here's the output. Let's look at the data. So for the points, we have the first participant and the second participant, as well as the duration of their meeting, all captured within the point data set. Now for the area data set, it's different because there's multiple meetings that take place in this one location. And so we have the total number of meetings, the durations, meeting times, start and end. So different data sets or different pieces of information for the area's output. Now let's take the meeting locations, and let's reverse geocode these to get the addresses. So I'm just going to look real quick, found the reverse geocode tool, and then we'll just go ahead and plug in our meeting locations points data, and then choose my location service. I'm looking for addresses, and we're just going to run this. Change the name real quick. And hit run. And this tool is usually pretty quick. There's our output. We'll turn off the original point feature class. We'll open up the attribute table. So you see all the same fields, but we've added this address or place field, which is going to be key, and then just like all our geocoding process, a lot of extra fields we really don't need for this analytical workflow. going to the field. So rev_address is that address or place field. So we need to take note of that for later on. Okay, let's zoom back out. Now let's put a link chart together and find some connections and relationships within these data sets. Okay, the first entity we're going to add is going to be the meeting locations. This is where we have to use that rev_address field earlier from the reverse geocode. And we'll just call this meeting locations, hit OK, and we'll see all these features get added to our link chart. Next is going to be the GPS data. We'll use that GPS ID field. And the great thing about this is it's 156,000 records, but it's all consolidated to the unique identifier for each entity. So it's only 57 because that's how many devices are being tracked. Okay, and so now we need to create the relationships. So we'll use the meeting locations and the GPS data, and we'll create a relationship between that first participant and that GPS ID field. And we'll do the same thing now with the second participant. And this is helping draw those lines to show us the relationships and the connectivity within our data. Let's choose another layout. Use organic. And let's put some labels on here so we know what we're looking at. Okay, that's better. And we'll use the clustered layout now. And so we can see our relationships between the meeting locations and the individuals being tracked in GPS. Let's select these meeting locations and these three individuals that seem to be related. And we'll move this over so we can see our selection on the map. Everything we do in the link chart shows up on the map and vice versa. And we can see these three individuals and all their tracks and where they've been. But this is a little hard to discern with all the other GPS information. Let's export this out to a separate data set real quick with just the three individuals so we can conduct additional analysis. And let me grab change the symbology real quick. Actually, I'm just going to pull it in from that other layer. That we don't have to mess with this. So let's import this in. There we go. Okay, so now we have our three individuals on GPS tracking symbolized. And let's go ahead and put the link chart away for now and just look at the map. Okay, let's go ahead and use the Code Traveler tool. Remember, for Find Meeting Locations, that was looking at points that dwell in the same place temporally and spatially. Now, Code Travelers, this is going to be the GPS point information with this temporal tolerance. And so we'll just fill this out, let it run, and then we're going to be able to see additional points where their paths may have crossed, or maybe they're traveling at the exact same time together. But it was only for a brief period of time, so it's not a meeting. It's just a very short temporal overlap in their locations. Here's our output on the map. The yellow to red variant. Let's zoom in to identify any additional locations outside of our meeting areas or meeting spot points. Looks like these two are traveling together. We also have a lot of activity up to the north and then down here by the meeting location. It actually, when you zoom in, it looks like this is their houses. They happen to be next to each other. So that makes sense. So, but then as we go up here, up north, when we look at this, they're at one residence and they're definitely together for a prolonged period of time. Okay, let's zoom out, see if there's any other co-traveler points that we need to look at. No, nothing, so let's turn that off. What else can we do? Let's go ahead and move this down here real quick. And then let's pull up the points to track segments, which is actually a combination of the old points to tracks tool and I believe incident sequence. So those are two now. So we'll just put in the people of interest for those three individuals. Just use the date field. And we'll run this. And we'll just give this a second. And there we go. Two outputs, a point output, and then the line. I'll zoom in, you can kind of see the connect the dot, the sequential order of the points, 1 all the way through 23, and it keeps counting throughout the day, beginning to end. You can see that we have our three individuals. This one in the light pink is not as relevant. And so let's go ahead and make some changes to their symbol so it's not as prominent. These transparent symbols are a little bit harder to mess with, so I'm just going to go ahead and change the font size and make it smaller so it doesn't stick out as much. Apply that. Okay, and now that that's done, let's go ahead and turn the lines off real quick, and let's use the time slider and see how these points play out from the beginning of the day onward. First, we'll enable the time. I'll zoom out a little bit and then start the time slider. So what I'm using here in the time slider, just 15-minute increments, and I slow down the playback a little bit so you can get a good feel for where these individuals are and which direction they're traveling. And then it also helps us identify when they're co-locating at the same time. So you see this one individual dwelling right here. And it looks like they're alone. And then the other individual looks like they're traveling from east to west. Yeah, they're definitely alone. Where's the other? Oh, there they are, out there to the east. So here we have our other individual, and we know at some point that these two data sets are going to come together and dwell at the same location. Okay, well, that's the time slider and the GPS parolee data using the movement analysis tools in ProIntel. Before I go into the second demo, I'd like to cover the last movement analysis tool being released at 2.6, Compare Areas. If you have several areas that are relevant to your analysis, such as multiple houses, businesses, or as you'll see in this next example, several banks that are part of a bank robbery series, Compare Areas associates nearby intelligence to draw potential correlations between multiple areas of interest. Before we get started, there are a few terms I'm going to use that you should know. In the last demo, we used the link chart to create and visualize entities and relationships. In this next demo, we'll do the same and then utilize a couple of the new link analysis tools. One of the questions I often get is to explain the difference between a link chart and link analysis. I'd say the differences between the two is the same as visualizing data on the map, which is comparable to that of a link chart, and conducting analysis on that data, just like you do in Pro when you're conducting spatial analysis. The same goes for link charts and link analysis. One refers to the visualization and interface, and the other around analytical tools. In the second example, we'll use the Compare Areas tool in link analysis to try and identify potential leads for a bank robbery series. In the scenario, 4 bank robberies on 4 different days at 3 different locations have occurred. It's 3 banks because one of the banks was hit twice. In addition to the bank locations, we'll leverage a dataset representative of mobile location data obtained via court order. This handset location data around each bank is aggregated to a single layer we'll call handset data. And here you can see our 3 banks on the map, but with 4 dates for each of the incidents. And then we also have our timeline here at the bottom showing the 4 incidents across the 3 banks. Let's open up the data here real quick on the banks. You can see their name, their address, and the date they were robbed. And then the handset data, we're going to have the handset unique identifier, lat long, and then a timestamp. I'll close that out and minimize the timeline. Okay, let's zoom in. And here we have the handset data, which is a 100-yard radius around the bank. And then here's the buffer we're going to use for the Compare Areas tool. So let's open up that Compare Areas tool real quick. There it is. And we'll put in our handset information. And then that 100-yard buffer around the bank. Just leave the default output name. Here's the handset ID. Just use the, right there, the name of the bank is right. There it is, okay. And run that real quick. Okay, and there's our output, which is a polygon. Let's open it up real quick and we'll see what we have. We have the name of the bank, the handset ID, and then the total count of how many times that handset ID was within that polygon, which is around the bank, which this represents handsets active around the time of the robbery. Okay, we'll zoom out. Okay, let's move this timeline and make some room. And then we'll create that link chart and do some link analysis. Okay, let's add the banks. So the entities we're adding are the banks right now. Let's use the name, call it banks. And there's our 3 banks. And then we'll do the same thing here. This is for the handsets. We'll add those. Okay, we'll just let these handsets load. Okay. Let's go ahead and rename this layer while we're waiting. Compare areas. Handsets to bank. So this is that output that ties the 2 data sets together. To create this as an entity, because it's an analytical output, it's the connectivity between those 2 pieces of data, so we can visualize the relationships. We'll let that load. Okay. So those are now all loaded in. So for the relationships, we're going to take the banks and relate them to the compare areas. Just call it banks to compare area analysis, and then we'll tie the fields together, which is just going to be based on the name of the bank. And the link chart creates those lines depicting the relationships. And then we'll just do the same thing now for the handsets to the compare areas. And we'll just call that handsets to compare areas. And then we'll just use that handset ID to tie these two together. Change that layout real quick to clustered. Okay, it's a pretty clean layout. So now that that's done, let's go ahead and use the link analysis tools. Let's calculate the centrality in this network. It happens pretty fast. You can see obviously the banks are more central or have a higher score than the rest of the entities, which makes sense. We'll reorder these. There we go. Now we got the banks at the top, and then that fourth score, which is going to be a handset, which is right there in the middle, has the highest centrality score. And obviously, as you can see from the link chart, has connectivity to all three banks. Okay, now let's look at clustering. So clustering just looks at the entities that have the most connectivity within the network. So these are two popular link analysis tools, and I just wanted to show what those look like real quick. There's many others, but I figured I'd show a couple of the popular ones. So it's pretty obvious which handset is related to more of these the bank robberies, or was at least in proximity to these banks during the robberies. So let's go ahead and get an understanding what the ID is on that handset, so we can do further analysis and pull some data on this handset. Okay, so we got that. To save time, I've already done a pull on that handset and have a data set right here that represents that. So let's go ahead and I'll just turn that on. So we'll just call this the suspect movement data, and we can see all their location information around these banks over a period of time. I've run the cluster tool, and we get an idea of where this individual dwells more times than not. So obviously drives along this strip a lot and is near the banks. So maybe it's just coincidence that they're near them. And then right here, we'll zoom in and we'll get those labels. So it looks like this is around where their home is. And with this information, I can further my analysis on this individual, or just pass this off as a tip to the investigators. I hope that was beneficial for you. A few more things to share before you go. ProIntel utilizes your current ArcGIS Pro licensing. You can use ProIntel with Desktop Basic, or unlock the application's full potential with Desktop Advanced, Spatial Analyst, Network Analyst, Locate XT, Image Analyst, and 3D Analyst extensions. Since the release of ProIntel, we've received a lot of requests for training. Esri is in the process of creating training materials for ArcGIS Pro Intelligence. The training seminar series for ProIntel is scheduled to be released around September this year. The series seminar will consist of a few short videos, with more videos scheduled to follow next year. The training seminar will be available on Esri's training site to all customers current on maintenance. If you enjoy the content in this session, go check out the live streaming session on ArcGIS Intelligence Solutions on the 14th at 1:40 Pacific Time. Please reach out to me if you have any questions, analytical or workflow challenges, ideas for the product, or you just want to talk shop. Thank you.